Welcome to Algebra 2. This video is specifically made for explicit and recursive definitions of arithmetic and geometric sequences. We'll start with recursive definition and like how do we define it, and I think like recursive is one of the easiest definitions that we're going to talk about. Is already the way that we think. That's how I would define it. And I mean there's a proper definition of it. It's like taking the previous term. The new term is formed by taking the previous term and either adding or multiplying a constant with it. If it's adding, it's arithmetic. If it's multiplying, it's geometric. So we'll start with arithmetic and just talk about that. So arithmetic, you'll be adding, right? So let me give you an example of that. 2, 4, 6, 8, and so on. If they ask you to figure out what is the recursive definition for this sequence, and they do not tell you if they're using the first term as 1 or 0, because let's say two different routes where they actually say that a of 0 equals 2. If they don't say that, if they don't specifically say this, or they simply just write this, always assume it's a of 1 equals 2. Perfect. And I think that's the very first step is right here. That's your very first step, even in recursive. Recursive definition is a 3-step process. First, define your first term. Second, define your next term. Not define your next term. It's like give an expression of how to get the next term. So you would say a of n equals a of n minus 1. In plain English, it's saying this: hey, every new term is taking the previous term. In this scenario, adding 2. Add 2 with it. And see how the n minus 1 is like on like the subscript of it, I would say, like it's in the bottom right. It's always going to be in the bottom right because it's talking about the previous term. It's the position of the term. You see, if it's in the bottom right, it's the position of the term. Here, the position of the term is 0. The 0th term is 2. That's what they're saying. Alrighty, and then define your n. The way that you define your n is this. They already use 0, right? You don't have to use 0 anymore. You cannot plug in 0 anymore, because if you plug in 0, you get negative 1, which you don't want. So, there's two ways you can write it. You can say n is greater than 0. So 1, 2, 3, 4, 5. Do not include 0, or you can say n is greater than or equal to 1. Both of them works. See if you can write an expression for this one. Pause the video and see if you can do that. I'm going to do that right now. A of n equals a of n minus 1 plus 2, where n is greater than or equal to 2, or n is greater than 1. That's it. We're done. That's an arithmetic. Geometric would just be the same. Instead of adding, you'll be multiplying. I am giving you an example of geometric just so like you have an idea of what it looks like. 1, 3, 9, 27, and so on. If you're given this right now, you're not given what do you call that? Like if they don't define you the first term, so always assume it's gonna be 1. A of 1 equals 1, and then you're gonna say a of n equals a of n minus 1 times 3, where n is greater than 1 or n is greater than or equal to 2, and you're done with your geometric recursive definition. That's it. It's just that easy. 3-step process. Step 1, step 2, step 3. Coolio. Moving on, let's do explicit. That's going to take much more time. For explicit, I'm just going to talk about that in like detail, so it might take a long time. Let's start with arithmetic explicit. Arithmetic explicit. And before I do that, I need us to connect with stuff before that we already done. When you did arithmetic, you figured out that the graph that was forming was a linear function graph, meaning it was a line that you were forming. It was a straight line, right? Either increasing or decreasing if you're subtracting. One of those. If it is linear, we know there's an equation for that. what is that equation? That equation is y equals mx plus b. So oh my god, yeah, this is cool. Okay, y, I'm going to talk about that in terms of sequence. I'm going to convert this into sequence now. Y is your ace of nth term, the nth term that there is, right? Ace of n. Your m is your slope in this definition, and it's also in common difference in your what do you call that, in your sequences. You have common difference, right? Your x is your n term. Your b is your y-intercept. Y-intercept is when x is 0, so when n is 0, ace of 0. So if I combine all of this information together and had to write this as into the sequence, I would say this: ace of n equals dn plus ace of 0. Cool. That's the form. And that is the formula that I have used in the homework as well, a lot. But yeah, I have a okay. Oh my god, this is perfect. Okay, cool. It's gonna take a lot more time as well, but we'll get through this. Okay. So, how can we use this to leverage to figure out the nth term? Let's do that. N, ace of n. Let's say you're given this 0, 1, 2, 3, 5, 8, 11, 14. This is arithmetic. We can agree. Let's move on. Let's see if we can figure out an equation using this. Ace of n, I mean, you're trying to figure that out. That's your y, right? Your difference here is 3n plus ace of 0 is 5, and you're done. That is your equation. Cool. 3n plus 5, and see if it works. Well, also you have to define your n. N is greater than or equal to 0 in our case. Okay. Let's see if it works. Plug in 0. 3 times 0 is 0. 0 plus 5 is 5. Plug in 1, and my answer should be 8. 3 times 1 is 3. 3 plus 5 is 8. Plug in 2. 3 times 2 is 6. 6 plus 5 is 11. Plug in 3. See if you can do that, and see if you get 14. Alrighty. Now, I'm going to just like mess with you now, like mess with your brain. What if I erase this and move everything up? 1, 2, 3, 4. Now plug in 1. 3 times 1 is 3. 3 plus 5 is 8. That is not your term. So there is another equation that you have to create for that, right? See if we can create that. Okay? But so in order for you to do that, here's what you have to do: ace of n plus dn plus ace of 0. Ace of n equals dn plus ace of 0. Ace of n equals dn. Your difference is 3. And what is the 0th term? Do we know your 0th term? Do we know our 0th term? We don't know our 0th term, right? Can you figure it out? Well, let's see if we can figure it out. As you're going up, like 1, 2, 3, 4, you're adding 3. As you're going back, you're subtracting 3. So if I have to find the 0th term, I will have to subtract 3 one time, which will be 2. So if I had to write that, I mean, I'm going to write it here, so it's 3n minus 2, and will work, right? And see if it works. Plug in 1. 3 times 1 is 3. 3. Wait, I mean plus 2. That's one. I was like, wait, why is that working? It's plus 2. When you subtract 3, 5 minus 3 is positive 2. I don't know why. I think I was subtracting 3, so I was thinking it's negative 2. That's why. Okay. Plug in 1. 3 times 1 is 3. 3 plus 2 is 5. Plug in 2. 3 times 2 is 6. 6 plus 2 is 8, and so on. But n, you have to define it. N is greater than or equal to 1 in our case. You don't have to plug in 0. You only see. You might wonder 0, but this is your sequence. 0 is just your way to get to the equation, right? It's your path to get to the equation. But you're always going to say your starting term, which is 1. But knowing this information, can I not say that ace of 1 is ace of 0 is ace of 1 minus the difference? I can say that, right? Yes, I can say that. Yep. See, I use the first term, subtracted the difference to find my zero term. What if I use this to plug in here and plug it in here? What would that look like? A sub n equals dn plus a sub 1 minus d. I'm going to rearrange this so that the d's and these two terms are closer to each other. You get a sub n equals a sub 1 plus dn minus d. So you get a sub n equals a sub 1, factor out a d, you'll get n minus 1, and that is the explicit equation that will be given to you on the quiz, on the test, and on the EOC. Whenever you have sequences, this will be given to you. But you see how different it is? Compare them, okay? This is the equation that we just created, using some logic, and this is the equation that we've been using before. What is the difference? And these two will get the same answer. You have to know that it's a sub 1 and when you're given a sub 0, right? You just have to do it correctly, if that makes sense. I'll give an example of that right now. But look at the difference, right? We just see the only difference is that here you're using the zero term in this equation, you're using the zero term, and we actually use what zero term means in arithmetic to figure out what using a sub 1's term. So, given an equation, I'm given this, let's just say that, okay, given this 9, 19, 29, and so on. Let's say they define this using 1. Like they don't even say anything. They just give you this and they ask you to figure out the nth term. That's all they say. How do you figure out the nth term? You can use any of these. I'm going to use both of these to see if we can figure out, if we can understand how it works. Okay? I'm going to start off with this one because if it's multiple choice, you're going to have to use this one. Okay? The first term, a sub 1 is the first term, which is 9 plus n minus 1, leave it as it is because n is your x, right? Difference is 10. If it's multiple choice, they might just ask you to stop right here, where n is greater than or equal to 1 and you're done. But even if it's multiple choice, they might ask you to simplify it. So you might have to do this 10 times n and negative 1 times 10, so you get 9 plus 10n minus 10. And 9 minus 10 is, what is 9 minus 10? Negative 1, oh my god. Negative 1 plus 10n. So that's your answer. Right, where n is greater than or equal to 1. Now, I will use this method. So, a sub n equals a sub 0. How do I get, this is the first term, I need to find the 0 term. Don't say it's 9 because that won't work. So, you might have to like jump backwards and subtract 10. See, if you're jumping forward, you're adding 10. If you're jumping backward, you're going to subtract 10, right? And 9 minus 10, we did that here as well, 9 minus 10. Isn't it interesting? So, if you use this, you're skipping a step of simplifying it. You don't have to do that because it's already been simplified for you. 9 minus 10 is negative 1 and the difference is 10n and you will get the same answer. Ooh, interesting. Fun. Alrighty, let's do explicit geometric. Now, just how y equals mx plus b is arithmetic, there is and linear. Geometric forms exponential, and we say this: y equals the y-intercept. Let's call that variable a sub, or let's call it b. Since it's y equals mx plus b, let's call that b. The ratio is the rate at which your exponential function is increasing or decreasing, kind of thing. That's your ratio or growth factor to the power of n. Well, that's connected. Again, y equals a sub n, or here it's x because it's a function, so we're going to use x. B is your y-intercept, also known as a sub 0. It's the same thing. R is the ratio at which it's increasing your sequence. X is your n. So let's rewrite this as sequence, in terms of sequence. A sub n equals the b, which is your a sub 0th term, the ratio to the power of n. That's it. That you're done. Okay. Let's do an example of that. Quick example of that. 1 2 4 8 dot dot dot. That's your geometric sequence. How would you use that? Quite simple. But I'm going to use it as a table for now, so I can do the same thing that we did. Use 1 2 3 4 1 2 4 8 16. Coolio. So they define using zeros, right? So it's easy now for you to use this. If they don't do that, always assume it's 1. I'm gonna stop in saying that now. S of 0 is 1. The first term is 1. Ratio is 2 to the power of n, where n is greater than or equal to 0, and you're done. That's your geometric sequence for explicit. This, you won't be given this. What you will be given is this. And actually, let's take a step back. Let's see if we can figure out how I derived it 15 centuries ago. Well, no, 5 centuries ago. 20th century. 5 centuries ago. Okay. I'm just gonna erase this and write this as 1 2 3 4. We will omit this part for now. Let's say that we won't include this. This is your first term, 2 4 8 16. You're asked to figure this equation out. Let's see how to do that. How would we do that? Well, if you're going to use this formula, you're going to have to divide 2 1 to get 1, right? You have to do that, right? Yep. So you will get S of n equals 1 times 2 to the power of n, which is the same thing as this. Hasta mañana. But there is a big problem. What do we do with, how did they get this formula? S of n equals S of 1 times r to the power of n minus 1. How do we get this from here? Here's my question. We step back. Didn't we divide? See, in arithmetic we subtracted, right? Here we're going to divide. So you're saying that S of 0 is S of 1 divided by the ratio. Can we agree with that? You're dividing, right? So I'm going to use that and plug it in here in this equation. You get S of n equals S of 1 over the ratio times the ratio to the power of n. Can you see something cool? I'm going to show you something awesome now. Okay. 2 cube, sorry, let's just do x cube over x square. Exponent rule says that this 2 will be subtracted from 3 if you combine the bases. 3 minus 2 becomes 3 minus 2. Same thing here. R to the power of n, r to the power of 1. This 1 will be subtracted. S of n equals S of 1 times r to the power of n minus 1. And you're done. So that's it. If you're given the first term, just use this formula. If you're given the first term as 1, use this formula. If you're given the 0 term, use this one right up there. The only difference between these two and how do we remember it is that let's write them down. Let's write them right next to each other so we can see the clear difference between the two. The clear difference is this. Look, this one, if you're starting with a1, you're gonna have to divide by r one time. That's why this negative 1 exists, right? So if you're given the first term as 1, do S of 1 times r to the power of n minus 1, and this will be given to you. So if this is given to you, how do you get this from this? Just change this 0 and remove this negative 1, and that's how you get this. Alright, that's pretty much all that I have for this video. If it still doesn't make sense, do some examples and ask ChatGPT, see if we can give you some examples and see if we can do that. Alrighty, I will see you. If you have any questions, let me know.